Hello everyone. In today's session, we'll be discussing about stack operations in ARM7. Stack is nothing but a dedicated area of memory which is used to temporarily store some data, and it is very much useful during function calls and exception handling. The reason for that is using stack you can easily store the concerned registers, return addresses, or any data during subroutine execution. First of all, it operates with the concept of last in, first out. What do you mean by last in, first out? To understand the concept of last in, first out, let us discuss how plates are placed and removed on some random table. Okay, so let's assume this is the first plate which is placed on a table. Okay, if I want to place the next plate, where I'll place it? I'll place it here. What about the next plate? I'll place it here. So this you can consider as storing some sort of data. Now if I want to remove one of the plates among these three plates, which one will I remove? The top one or the bottom one? I'll always remove the top plate. So that is last in, first out concept, and same concept you will see in stack. Okay, and this operation of storing and removing data from stack, in general context it is called as push and pop. Whenever you store some data in stack, it is called as push operation. Whenever you remove data, it is called as pop operation. Okay, now let's just see what happens in a stack. Let's assume this is the memory we are talking about. This is the higher memory address and this is the lower memory address. Okay, and in between these are the consecutive memory locations. Okay, so now since this memory is a stack, there comes the concept of stack pointer. Now let's see what exactly is a stack pointer here. So a stack pointer is nothing but a register, and this register in case of your ARM7 or LPC 2148 is specifically R13 register. Okay, and the purpose of stack pointer is to point at the top of stack. It points to the location wherein the next push pop operation is supposed to be carried out. When it comes to push pop operation in case of ARM7, as we expect in case of push, some register content that we specify in the instruction will be placed in the stack or into the memory location. Okay, and in case of pop, what will happen is the content of the memory will be placed in the desired register. Okay, but one thing we will note here is that in case of pop operation, the contents of the memory are actually not deleted. Just a copy of that will be placed in register and the stack pointer is actually updated. Okay, while the data which was previously present in the memory remain same until you overwrite it using push operation. When you consider ARM architecture, in order to perform these storing and removing operations, we use load multiple, store multiple instructions. Okay, and after learning all those, you will see that you will actually see push and pop as pseudo instructions, which we'll learn much later. So we have four different stack models, and I'll just specify the names here. Those are full ascending, full descending, empty ascending, and empty descending. So to understand this, you should first understand this particular concept. Very first thing we notice is a stack could be ascending or descending. It is very simple to understand this. That is, stack is nothing but a memory. So obviously only things you can do in a memory is either performing push operation or pop operation. So let's consider the first case wherein we start storing the data from the lower memory address and we start storing it to higher memory address in this particular fashion. So what is happening here? The stack goes from lower memory address to higher memory address. Then we have the next concept, that is descending stack. What does that mean? The initial data is stored in the higher memory location and the next set of data are stored in the next lower memory locations as shown here. Okay, so the stack here grows from higher memory address to lower memory address. Then you have the concept of full stack and empty stack. So what do you mean by full stack and empty stack? So we know that there is something called a stack pointer which always points to the top of the stack. Okay, the concept of top of the stack doesn't mean higher memory location. Okay, it means the location where the next push pop operation is supposed to be carried out. Let's assume this is the position where previously some data was stored. Okay, then there are two options for stack pointer. Either it can be pointing at this particular location, which is called as full stack, and second option is it will be pointing to the next location. So what does that mean? If the stack pointer always points to a location which is filled with some data because of previous operation, then it is called as full stack. And if this particular stack pointer always points at the empty location which is next to the last used location, then it is your empty stack. These are the actual instructions which we have to use to perform our required push and pop operation. I already told we'll be using store and load multiple instructions. These are those actual instructions. This makes it a lot easier because you don't have to understand what exactly is happening internally. You need to just know what stack type are we discussing here. If you know the stack type, for push operation you should perform STM, that is store multiple, and pop you have to perform LDM, which is load multiple. After that you should just specify the stack type, that is STM followed by FD means the stack type is full descending, so you want to push into that, so just write STM FD. And what about pop operation? Just write LDM FD. But what happens when you specify these instructions? Actually, these are just aliases and these are internally converted to these instructions by assembler. If anywhere in my code, if I use the term STMFD, I wrote it as STMFD because I know in my case it's a full descending stack. Okay, so in order to store I have to use this particular command, but internally what happens is it gets converted to the instruction STMDB, which is store multiple decrement before. This I have explained in detail what it is in the previous session, so for now I'll just specify what each instruction gets converted to. And what happens to LDMFD? If I write an instruction LDMFD, internally it gets converted to load multiple increment after. Okay, so if you want to understand stack operation, first you should understand how each of the store multiple, load multiple modes work. So this table is what you should remember. And one more thing you should know is, when you consider which exact stack type of stack model is used in case of ARM7, it is always full descending. The reason for that is we have something called as ARM procedure call standard. Okay, now this is nothing but set of rules used by compilers like Keel and operating systems to guarantee interoperability between different code modules. Okay, and this particular standard explicitly mandates the use of full descending stack model. Okay, so let's see one example to understand the usage of this particular instruction. Okay, that is STMFD and LDMFD. See, as already told, if you write an instruction STM, that is store multiple full descending, then it gets converted to STMDB, that is store multiple decrement before. But what you need to notice here is this term. What is this? SP refers to stack pointer, or it is nothing but register R13. This itself acts as your base register. in this particular case. And you can see an exclamatory mark here which ensures that even this gets updated with the new address. Okay, now let's just focus here. We have already learned how exactly STMDB works. Let's just have a brief revision of that. If you notice, I have kept a difference of 4 between two memory address. That is because in each box I'm considering 32 bit data which occupies 4 memory locations. Okay, so initially let me assume stack pointer is pointing at this particular location. This is just my assumption, or register R13 is pointing at this particular location. I'm trying to store. What value I'm trying to store? I'm trying to store the values present in R1 to R4 in this memory location. Let me just assume. So what will happen here? Very first thing that we know about these store multiple load multiple instruction is you have to always check what is the memory address. Is it higher memory address or lower memory address? Among the next set of addresses that we'll be considering for this instruction, this is the topmost or highest address. Then the address keeps on reducing. So which of this register content should be placed here? It should be R4 content. Why? Among these registers considered in the instruction, R4 has the highest order or highest suffix. Okay, so what is that value? Let me just place it 0x8. This is the first data stored. Where will the next data be stored? There it will be here, that is 0x7. Then which is the next position where data will be stored? It will be nothing but 0x6. Okay, then what is the next location where data will be stored? It will be 0x5. Okay, because it's decrement before concept, this particular stack pointer will be pointing at this location itself. Okay, so internally it got converted to this particular format. That's why we call this as aliases. That is, these are just other names for this particular instruction. Okay, and why exactly do you think we require these names? To make it easier. Otherwise you have to know which specific mode should be specified here. Some cases decrement before, some cases increment after, and all those things. So here you don't have to worry about all that. You can just write what stack model we are discussing about. Now let's consider the next case. That is, after performing store operation, how will you load this data? Let me assume I have some register R5, R6, R7, R8. I want to load all values from here and place it in this particular register. Then what I have to do? If I'm speaking about the stack model full descending, there is very little things I'll have to do there. I have to use the instruction LDMFD. Okay, so what happens here? See, the same thing as we noticed in the previous case, base register is stack pointer only, and the registers I have used is R5 to R8. So currently stack pointer is pointing at this particular position, that is the last position where data was filled. Now what I want to do, I want to perform load operation or pop data out and place it in these registers. So the very first thing I notice is this internally gets converted to LDM increment after. What do you mean by increment after? This is the lower memory address, and as per this instruction, as we continue loading data from here, we are moving to higher memory address. Okay, so if you notice here, which is the lowest address here? This one. And as per this instruction, we have registers R5 to R8. So which among them has lowest order? It is register R5. Okay, so because of which, when I perform LDM increment after, what does it mean? Initially stack pointer is pointing here, so increment after loading. So load the first data into the register R5. Okay, then increment. Okay, and what value it is? 6, so that will be placed here. Then what I want to do, I want to point at the next location, and that value will be placed here. And then I want to increment to next location, that is here, and that value comes here. But it is increment after. So where exactly the pointer should point at? It should point at the next higher memory location, that is here. Okay. Next, we have the pseudo instruction push and pop. As you can notice here, okay, we can directly use the instruction push and pop followed by the concerned registers. What exactly are this? These are nothing but pseudo instructions, because internally these get actually converted to the same instructions we discussed previously. Why is it specifically decrement before and increment after? Because we already saw while discussing the previous stack models that full descending is the stack model explicitly mandated. Okay, so because of which if you just write push and pop, automatically it's assumed that the stack model we want to consider is full descending only, and full descending instructions are in turn converted to store multiple decrement before and load multiple increment after instructions. And one more thing you can see is here we have not specified the base register, but automatically we know because it is push pop operation which are stack operation, base register considered will be stack pointer, or you can specify it as R13. So this is exactly same as specifying STMFD SP factorial comma R0 comma R1. This is exactly same as specifying LDMFD SP factorial comma R0 comma R1. Okay.